CAN protocol provides complete serial data communication, real-time support, up to 1 megabaud per second transmission rate, and 11-bit addressing and test functions. It is widely used in automation and industrial fields such as automotive control, safety monitoring systems, medical instrumentation, and maritime transport. Many Regal oscilloscopes provide CAN bus triggering and decoding functions that can help simplify development and debugging of systems using CAN. In this example, we are using a test board that features 1 megabaud per second CAN signal. The data contains a character string spelling Regal. The data length is 5, CRC check, with no response. Now let's take a look at how to use the oscilloscope to trigger and decode this signal. Connect the signal output pins CAN_H and ground to channel 1 of the oscilloscope using the probe. Press Auto, and the oscilloscope will adjust the time base and amplitude scale to proper values automatically. We are now able to observe the signal, but the scope is not triggering stably. To stabilize the waveform, let's configure the trigger mode for the input signal. We'll set the trigger type to CAN, set the signal source to channel 1, signal type to CAN_H, set the trigger conditions to SOF, set the signal rate to 1 megabaud per second, trigger mode to auto. For easier observation, you can also adjust the time scale. Now that we have stabilized the triggering, we can select the decoding option to interpret the signal information and display it on the screen. Press Decode, set the decoding type to CAN to enable the bus decoding function, set the signal source to channel 1 and the signal type to CAN_H, set the signal rate to 1 megabaud per second, set the display format to ASCII, and adjust the transmission threshold to make it pass through the signal. The data content of the signal is now displayed on the interface while keeping other settings unchanged. The signal information is Regal. Frame ID is displayed in hex digits in blue. Data length code, or DLC, is displayed in chartreuse. Data frame is displayed in green patches, or red patch if the data frame is lost. The cyclic redundancy check, or CRC, is displayed in light blue and also has a red error mark when an error is occurring. You can adjust the time-based scale to display more decoded frames on the screen, but at a certain point the decoded data cannot be completely displayed. Another useful feature is the decoding table. Activating the decoding table will display the decoded data, the corresponding timestamp, frame ID, DLC, CRC, and ACK information in table format. Select Event Table and select On to view the 10 groups of data nearest to the trigger on the screen. If a USB device is currently connected, press Export to export that data table to the external USB storage device in CSV format. This concludes the demonstration about CAN bus triggering and decoding using Regal oscilloscopes. The key points to remember: you need to select the proper time-based scale and amplitude, set the proper trigger conditions, set the proper decoding conditions, and then you should be able to observe the decoded data on the screen or in the event table. Thank you very much. Have a great day.